Hello, everyone. We will get started just in a few minutes, right at 12. For those who just joined us, we will be starting in a few minutes, right at 12. All right, Dr. Howden, are you ready if we begin?
I am.
Perfect. Well, thank you everyone for joining us. Happy HTM week. And thank you for joining us as we are going through our Migrating Passive RFID solutions into mainstream healthcare use, practicality, affordability, and powerful performance delivery and advantage webinar today. If you want to jump to the next slide, we would like to take this moment to give a shout out to our sponsor, Pycube, for enabling us to host this free webinar to our ACCE members. And the next slide. I'm Angelina. I will be your moderator today. I'm one of the education committee members for ACCE and a biomedical engineer with the VA. Prior to my role at the VA, I worked for Kaiser Permanente as a clinical engineer and technology manager. And I'm also a graduate of the University of Connecticut Clinical Engineering Program. Next slide. So just a few logistics before we dive into our fun topic today. Please make sure that your microphone is muted during our presentation. Any questions can be submitted via the Zoom Q&A feature. Don't use the chat, but you are able to use the chat if there is an urgent message, as we will be monitoring it as the panelists. Also, please remember to complete the survey at the end of the webinar. A link will be provided to you. And additionally, these slides will be posted with the recording on the ACCE website. I will turn it over to you, Dr. Howden.
Okay, thank you very much. I'm Dr. Bill Howden. From here and after, I'll just be Bill. My background is engineering and business. I worked for about 33 years, 34 years, something like that, in telecommunications, spanning design roles, project leadership roles, program leadership roles. Actually ran our factory for a while, producing equipment. Then went into large-scale systems and deployment of large-scale systems and so on. Eventually was a vice president, general manager over a global services division where we had operations in 18 countries, and we did work in about twice that, about 34, 35. So in that particular role, truly the sun never set. We were on duty, 24 hours a day. But then after telecom, I had an opportunity to take a parachute out of telecom, and I did, and then set up my own consulting firm, went back to college, and did a doctorate with a focus on data analytics, predictive modeling, technology adoption, and kind of an emphasis on those three things. And so what I learned in telecom and then learned in big data was you can create these systems, and a lot of customers just use them casually. But about 10% of the customers just live and die by the information you give them. And the passion for me became, how do you help every customer embrace it at that level? And so that kind of became my calling for the last 10 years or so. And how do I help companies that create solutions get those solutions into the hands of their customers And then how does their customers get a huge amount of mileage out of those solutions? So that's what I'm all about. That's what I do for Pycube. And I serve as our Chief Revenue Officer at Pycube, which is coordinating strategy across the leadership team. And then I'm responsible for marketing and sales and contribute technically as well. So that's who I am. So the session description, you probably read this, but just to touch on it, what I'm going to focus on, it's probably a lot of understanding the fundamentals. My life experience, the more you understand kind of the basics, the better decisions you can make as the basics start to get more complicated. So we're going to start with a real good understanding of the basics, gain insight into how that has evolved, what are the benefits of these type of solutions, what are various applications of those type of solutions, and then even follow up at the end with some successful case studies. And I've narrowed it to just the last few months, so you won't necessarily hear us talk about a whole lot of customer stories and all, but we'll summarize a few key points, but then talk about our field testing experience in the last 3 months. So this is how we're going to cover it. So I'll give you just a brief introduction to Pycube. This purposely is not a sales sales call, sales presentation. So we're not going to tell you, oh, how wonderful Pycube is, but just to frame it out. Who are we? Where do we come from? What do we do? Then we'll go through the origins of RFID. What are the types of systems? How does it work? What are maybe challenges then, business challenges in the solutions for healthcare space? And then what type of features, benefits do these typical systems offer, and what applications do they also target? And that'll probably get a little bit from a Pycube lens, just naturally that's where we see, but there will be other dimensions to it. Okay, so we'll start with introduction to Pycube. Pycube's about a dozen years old. We were founded in 2012, primarily a IT kind of / consulting firm where we did IT projects and ended up kind of focusing in healthcare. Their initial focus at the time was to create healthcare apps for people who couldn't afford them. So if you think of a large hospital, they have $15 million invested into applications like Epic or SAP or whatever. But a dentist practice can't really do that very well. So Pycube kind of started aiming at that and making apps for bringing technology to people who couldn't afford big technology. They ended up expanding into digitization almost by accident. In 2013, I think it was 2012, 2013, Hurricane Sandy was pounding the Jersey Shore and New York City. And basements were becoming flooded in hospitals. And unfortunately, that's where hospitals kept their paper records. So Pycube helped a number of hospitals and went into a scramble and moved them to New Jersey or whatever. All these boxes and boxes of credentials and data and records that were on paper, and then scan, digitize them, index them, created hyperlinks, all these legacy documents. And I was kind of just learning about this with our CEO a couple years ago and saying, man, you must have had like hundreds of thousands of documents. He goes, no, we were like at 7 million. So anyhow, they did a lot of work digitizing a lot of records, and that led to some other opportunities. One of those later became fast replenishment warehousing. So we ended up during COVID, especially, we set up several million square feet of warehousing, and whenever hospitals needed gloves and Purell or whatever it was, we kept those at our site and was able to get them to various hospitals in New York City area and Washington, D.C. area same day. And we managed the procurement and the supply line for those types of supplies. We got very good at managing that. And so, like, for example, our Washington, D.C. area warehouse, we went from, I think, about 16 employees down to 2. Still the same amount of square feet, same amount of product that went through. We started to create proprietary tools for ourselves where we RFID tag things and pallets and have schemes and structures to where we would store things. And we were able to do this very affordably for our customers. That then launched, wow, we really know how to do RFID. We really know how to do warehousing. And we really developed some software tools to help. Those ended up becoming our Active, which is Latvian, I think, for assets, and then SynCsense tags and the IoT that are the roots of some of our customer solutions. So that's Pycube. Our mission, we specialize in technology solutions, digital transformation, automating customers' processes that exist. We don't want them to have to start from scratch and create new processes. So we take their workflow and make our tools adapt to their work. And then we create operational business intelligence. The difference there is business intelligence is often, what's your competitors doing, what's the market doing, what's the stock market doing, and so on. This is operational business intelligence. How many infusion pumps do you have? Where are they? How many hours are they getting on them? Which ones need preventive maintenance? Which ones need replaced? Things like that. So that's the type of business intelligence that we provide to people who run the hospitals or healthcare. And what we enable our customers to do is improve their operating performance. So they do things more efficient, faster, more time for patient care. Reduce chaos is a big one. We haven't done a whole lot of scientific studies on this, but there are scientific studies that show that cognitive overload causes employee burnout, involuntary turnover, voluntary turnover of staff. And so whenever, nurse or whatever is really struggling with maintaining their particular caseload, and they can't find a particular infusion pump or something, and they have to pause what they're doing and go on a 20-minute or 40-minute wild goose chase, find the things they need, they're now even further behind and they're ready to throw their hands up in the air. And whenever that happens, 4, 5, 6 days a week, week in and week out, those people tend to start to get burnt out. And so having a reduction of chaos and increasing certainty not only improves efficiency, but improves things like less burnout, less turnover, and better employee attitudes, and better care for the end result of the patient. Again, don't have specific scientific studies that Pycube has done, but there's enough other scientific studies that reference that and prove that. And then finally, we help them lower their OpEx. So if you can do things more efficiently, you reduce your cost of operating your business. And in some cases, we can reduce CapEx. So in some cases, there's opportunities where equipment may need to be changed every, let's call it 7 years, something like that. And the hospital may say, okay, well, that piece of equipment is 7 years old and it's due to be changed. But what we understand is you can actually petition that, even though it's 7 years old, it's been perfectly maintained, and it's really only been used about 1 year. And so you can make a case to say, I'm going to keep that in play for another year or 2 or 3 or whatever it is. And then the hospital doesn't have to, I'll loosely say, overcapitalize to replace that in a really good year. So we help healthcare institutions lower their CapEx and lower their OpEx, and in some cases, lower their CapEx. This is a huge oversimplification, but this is kind of what our general Pycube solution looks like. So down on the lower left, there's a whole bunch of things. So we acquire data from those things via IoT. It could be RFID, it could be barcode, it could be Bluetooth, it could be a variety of ways where we grab information from those things. And then all the customer really needs to have for that is give us Wi-Fi access. So then that talks to the cloud. So then that information goes to Pycube's cloud, where we organize, store, format, and sort the information. We then process and analyze that information. And then on the far end, the customer just simply has a browser where they log in Pycube's Active solution, and you can pull down queries and get reports. You can have it push to, you can have it pull It doesn't matter. All of that data is available for analysis, alerts, information, and then we even develop and offer other analytic packs that can sit on top of that and tell you more specific information about your data. So, overview of RFID. What's its origins first? Well, first, what is it? It stands for radio frequency identification. So what it does uses radio waves to identify people, objects, whatever. And there's a device then that reads that information that's contained in a wireless device, often called a tag or a label, and reads it from a distance. And it doesn't have to make physical contact, and it doesn't have to even have a line of sight. It can be hidden around the corner and it can find it. Once you get that information, it will provide directly identification. So I'm tag number 1, 2, 3, 4, 5, 6, whatever. And then in your database, you say, oh, that's associated with a bed or whatever it is. So you know that you've just identified a particular article that's in that space, in that room, in that zone. Location, we can triangulate and or locate in a variety of methods to be able to say, yep, that particular device is in or near this particular room, and so we know where it is. Here's the last time we saw it. And then you can have reported or derived measures like motion, direction, speed, whatever. And what that can tell you is things, especially if you look at it over time, you could take, and I'll just loosely use the generic terms for pump and infusion pump. I'll probably say that 100 times, but it can be associated with anything. But you want to be able to say, oh, that device, that pump, has moved from a patient room to soil storage, to then clean storage, to then preventive maintenance, and then it's back in clean storage, and it's ready to be used. And it's made that cycle 4 times this week and 8 times this month, whatever it is. So you can start to look at the amount of cycles that something has taken. And we structure our data that you have the opportunity to either have it be static or have it be dynamic. And we also price it accordingly so that if the thing is static, you don't need to pay to track all of its motions. You just know it's in that room, it's a lamp, it's in that room, and it never really. So then there's other things that it can also tell you. Tags can report, depending on the tag, it can report parametric information like temperature, barometric pressure, humidity, a variety of others. So that's what RFID is. Where did it all start? It was World War II. Like in many cases, military and space race issues require acceleration of technologies, and they play a pivotal role in winning a war. So in the late 1930s, all of the forces that were flying in the European theater were using radar. So Germans were using radar, British was using radar, later Americans were using radar, and so on. But you couldn't distinguish well between your planes and the enemy planes. So what the Germans used to do was they would have their pilots roll in planes periodically, so the people watching the radar could then identify what planes were German planes. That wasn't always real good. What became better was Britain developed basically the route of RFID, where they outfitted their planes with a device that disturbed the radar signal, and they could see this disturbed radar signal and then identify it as their plane. So this wasn't the actual way it was, but if you look on the little radar map there, you can see I have a few planes identified where they have hash marks or whatever. And again, that's not an accurate depiction of what happened. That's just an illustration. But where you have a cluster of planes, you can see which ones are your own and which ones are not. That's where it all started. Where it evolved, and I'm not going to terrorize you guys with all the details of this, but it then evolved a whole lot in the 50s, 60s, 70s, where it started getting to be things like in retail tags. So I imagine many people, when this audience, you've gone in to buy a shirt, jeans, or whatever it is, and they go, oh wait, I have to take the tag off there or else it'll beep when you're leaving. So they have to put it in a machine and compress it and release the tags, and they throw it in the bin. Those are what are known as 1-bit electronic article surveillance. That it's either detects it's there or it's not there. So whenever you're leaving, alarm goes off and says, "I've just seen this," or it doesn't go off and says, "Okay, that must not be wearing a tag." Later on, it evolved heavily for passive RFID and even active RFID into a lot of transportation stuff, railroad, toll collection, entry cards. Some of the biggest changes became here in recent years, at least in the 2000s. What that is, technological advancements, totally outside of RFID, is cheap internet and cloud computing. So once upon a time where you had to have physical wired Ethernet LANs in a facility, a whole lot of wiring and hubs and routers, bridges, and so on. You could just have it be Wi-Fi. And then where you have to have lots and lots of servers and backup and storage and so on. Well, now that could just be in the cloud. And so those are two big enablers. And then also advancements in hardware and software styles to work with those advancements. Then some specific hardware changes. And I've spent a lot of my career in satellite communications. Whenever you have a big satellite dish, you're trying to see this tiny signal coming from like a 1-watt signal that originated 22,282 miles out in the sky. It is so tiny that you couldn't get it with the regular antenna. So you had to get it with a pretty big antenna to collect all that energy. And the amount of just general heat would cause enough background noise that you'd never be able to see the signal. So they would actually cool them with giant refrigeration systems, glycol, to keep these what's called low noise amplifiers very, very cold so that they could detect the weakest signal. Well, then, sure enough, came along what's known as gas, gallium arsenide. And that allowed a very noise-free transistor, if you will, gas FETs, field effect transistors. So these gallium arsenide receivers became these very low, very high gain devices at the front end of an antenna. So you got the ability to see very, very weak signals being reflected back to the readers. So that allowed these antennas to become much smaller in size, have longer distance, and then have relatively high gain to have power efficiency. So a 1-watt transmitter can reflect off something and get a billionth of a watt back and still read it successfully. That was huge. I already talked about Wi-Fi and cloud computing, and then finally IC integrated circuit, and specifically ASIC, application-specific integrated circuits. And that's what allowed a whole circuit board, if you will, to be miniaturized down to a pinhead and put on your credit card, or wherever. So these tags became pinhead-sized chips and tags. They still needed bigger antennas, but they became very small chips. So what are the different types of RFID? So there's different transponder types. So let's say primarily active and passive. So active is where these tags are about the size of the head of your wristwatch, and they're strapped to a device. They wear a battery and they ping out periodically. And the more often you ping, the more battery power it takes. But it might ping once a day, once an hour, whatever it is. And there's location engines like receivers all spread throughout the facility or room, and they intercept that ping. And then by virtue of processing, they can determine, yeah, that ping is here in my room with a reasonable degree of certainty. The benefit of this is that those battery powered ones can go long range. There's a friend of mine who is German that works for Mercedes-Benz in Bremen, where the cars come out of the factory and they go to the loading docks at the Bremerhaven at the harbor. And so you have thousands of cars in a parking lot, and they don't all go in the same, they don't come off the factory line in exactly the same order that they need to go on various ships, cargo ships. So they have to put them in various areas, then go find which cars go onto which ships. And so they have receivers up on streetlights, and the cars all wear these tags, and they'll ping every hour or something to know where that car is. And then they'll go and get that car and drive them onto various ships. And that's a really great use for this longer range battery powered device. These are often called, you'll hear the term RTLS, real-time location systems. It's colloquially called that. In truth, both systems can be equally real-time. A passive system actually has an advantage there, that these active systems with a battery, if you really want them to be real-time, and they're not, it's the last time I heard from it. So if I heard from it an hour ago or 15 minutes ago, that's where I know it was an hour, 15 minutes. But if I wanted to hear every minute, every second, every 30 seconds, or whatever, program it to do that, we'd have a whole lot of data riding over the network, but it could be done. But with a battery located one, a drawback is that you'd have to change the batteries very, very often, like every day or a couple of days, to be able to maintain that. So anyhow, the trade-offs, longer range, high cost, large infrastructure, but they're real good in real big, broad applications. Passive system, by contrast, is much different. It's very much like your easy pass on your windshield. A transmitter, you're driving under the toll booth, a transmitter blasts power down to your tag, wakes it up, disturbs the reflection of that transmitted signal, and your transmitted signal reflects that disturb. You can think of it like it bursts back. It actually does not. It disturbs the signal and then reflects back. So again, all the same thing. You can tell proximity, location, reference, what car was it, and so on. You can also use phased array antennas that will look at vectors rather than triangulation, and to be able to determine location, proximity, and so on. And again, both systems types can be RTLS. The passive system, you could make it ping every second, and it would be very real time. And then with no trade-off, the batteries never did it. So the trade-off for a passive system, it's very good for short and mid-range. It's very low cost, smaller zero infrastructure. Incidentally, Pycube just launched our what we call the Easy series, is zero infrastructure solution. I'll talk about that a little more later. But they're also very, very low maintenance. You put a tag on something, and probably unless you physically damage any of these tags, active or passive, with a passive tag, unless you really break it, it's pretty zero maintenance. So then the next type is field or range. Far field, like having the cars in the parking lot, as I described. Far field is defined as greater than one wavelength of the RF. But again, for assets, inventory, people, whatever, passive can be far field as well, in room size or a zone or a warehouse. Near field is where it's no longer RF coupling, it's magnetic coupling, and it's like these point of sale or even entry cards. And then low power near field is like your credit card, where you have to touch it like within an inch to be able to scan your credit card. And that's on purpose because you don't want it going more than an inch and reading somebody else's credit card. Actually, I'd be happy to read someone else's credit card, but I don't think the bank likes it. So whenever you look at the spectrum, there's low frequency, high frequency, UHF low, and then UHF high. Most passive, there are passive in UHF low and passive in UHF high. But the read range for these, let's just look at UHF low, tends to be about 3, 4, 5 meters. Actually, at Pycube, we've been doing a lot of theoretical evaluations and empirical tests that validate our theoretical evaluation. And we have had ones come up to about 37 feet, 38 feet, something like that, that are still reading 38 feet away with a handheld reader, or in some cases, a fixed reader on a cart. So operationally in a room that has a whole bunch of other stuff, that probably, even if you'd be rated like 50%, you could probably get something like 18 feet out of that. So we see plenty of places where we have been able to go from 10 to 12 to 18 to 20 feet and have high efficacy in reading. But you can kind of see, this chart, and everyone will get this at the end. This trade-offs costs. Is it affected by water? How much power source? What's its power source? And so on and so forth. What are like the typical healthcare implications? So let's get to how does it work. I kind of covered this, but we'll do it and let one more layer. So if you think of a flashlight, if you will, you aim a spotlight at like a white ball, but it has movable black shutters in front of it. Those black shutters are connected to a photocell, which harvests power from the light. That's this thing. And then it closes and opens the shutters in a specific pattern. It uses that motor. So if the shutters are open, the light comes through, it hits that white wall behind it, and you get a moderate reflection that goes out of the screen. However, if the shutters are closed, you get a very small reflection. So then, if you now open and close it in a particular sequence, like you see here with this, where the message controls the motor with a particular message that it wants to transmit, then the shutters are opening and closing in a particular cadence. And then what that allows is this light is reflecting or being inhibited in a particular cadence. And then the reader can interpret that as, oh, that's tag number 1, 2, 3, 4, 5. So that's the essence of passive ID. Where does it fail? Where does it fail and what causes success? There's two types of failures. When the distance is too long, let's say you wanted to go 50 feet. That's a pretty good distance. And depending on the reader, depending on the tag, probably won't make 50 feet unless you have a high gain antenna. Well, let's even go further. Call it 100. It's really not going to go very well 100 feet away and be able to reflect. So there's two types of failures. Forward fail is enough signal isn't getting there to activate the motor or wake up the tag. And then the backward fail is where the tag's trying to modulate the signal and it's so weak that either it's not doing it right or it's not being read by the reader. So that's the two primary modes of failure. I mean, there's another one, like if you took a hammer tag and beat it to death or something, broke the chip and broke the antenna, that can cause a failure too. But just from an RF perspective, there's a forward fail of not enough signal to activate the chip and a backward fail of not enough signal energy to be read by it. So what's it take to make it successful? You're close enough and you have enough forward light in this example. The chip wakes up, the motor gets activated, and it modulates the light. The modulated light is received by the receiver, and it can be decoded into some simple identity. And then the software in the cloud or wherever on a server performs the recognition, location, and whatever analytics you need. So the solution components, so that's what I just showed you in this example with light. If you just transfer the word light to RF, it's exactly the same. So that's the fundamentals of how it works. So then what does it need to make a solution? Well, you have a transmitter that emits this pure tone, just like, the flashlight's light bulb. The antenna aims the signal in that particular direction, makes it into a spotlight. The tag gets activated from that pure tone, and it disturbs or modulates the signal with those shutters, if you will. And then the reader sees this reflected signal, decodes it, and then the software or the cloud, the savant, then makes that into usable response. Also down at the bottom, there's more components that you can utilize in complex systems, like choke points and fixed antennas and so on. But generally, this is the essence of the solution. So here's a simple circuit, and don't worry, I'm not going to take everybody through the math. But you use, in this case, a handheld reader, and the energy leaves the reader, goes to the antenna, which is that flat face there. Can everybody see my cursor moving by any chance? Angelina, can you see my cursor moving?
Yes, we can. You have it in the top left.
All right, thank you. So this device is the handheld mobile scanning reader. So the power leaves the reader, goes out to the antenna, and it's that piece in the front. It has to go through free space, go through this obstruction, hit the tag, wake it up, harvest power, transmit back, that will reflect back. That reflection back has to go through the same obstruction, like a wall or whatever, and or glass, and then free space at the antenna, and then over here the math, which I will not take you through, and if somebody wants to connect with me later, I gladly will. But it sort of shows, starts with how much power do I emit? What are all the gains and losses? How much do I end up with? What's the minimum threshold? And then how much margin do I have left over, which quantifies like how good of a circuit that they have. This is what a physical tag looks like if you look at it under a microscope. So you see a bunch of conductors that is basically an antenna folded on itself, a storage area, and then a tiny chip right there. And so the antenna receives the energy, stores it momentarily, wakes the chip up. The chip also serves as the shorting device to short out the tag and create a signal that looks like this, where I have a full signal, then I have a disturbed signal, a full signal, then a disturbed signal. If you deconstructed the tag, this is kind of what you'd see. Adhesive on the bottom, some level of substrate, the antenna itself, the chip gets applied, it has some facing, and in some cases an encasing. They come in various sizes, or what's known as apertures. So you can have it all the way from the size of that like tiny one, you know, down on the quarter to one that this person is holding in their hand. The two of those have a difference of 504 times difference between their effective square footage per inches. That equates to about a 54 dB difference in how much you can absorb. And that's between 10,000 and a million. So that's probably about a little over 20,000, maybe 30,000 ratio difference in power that you can generate. This is the types of RFIDs. So there's ones that are called a dry inlay. They're a full assembly, but they don't have any adhesive on them. Then there's ones that are called a wet inlay. They're all of the things I showed you, but they add adhesive. And then there's ones that are RFID label, but they have everything, including adhesive. You run them through an RFID printer, and you print things on them. Actually, you can do this on the other ones too. And then there's some of them that are used for, could be used better on metal, metallic items, or they're metal-based tags. Okay. So let's look now at what are some of the challenges in healthcare and then the solutions. So the challenges in healthcare, this is from our research, published research, people you talk to, people that you talk to at a trade show, people you visit to talk to. The problems in healthcare for equipment, especially small and rural hospitals, is access to technology. So in a small rural hospital, small community hospital, the scale of the solutions until now has not been real ideal. They have been very large, if you will, so consequently, a small hospital can't really afford that, a very large solution. Geographical distance, especially for rural, the availability of local technicians, technologists aren't necessarily next door in a rural setting. Financial constraint, initial cost to get going, CapEx budget, probably can't handle a multi-million-dollar expenditure. The recurring cost, OpEx budget probably can't handle not only the monthly cost, but the amount of staff you need to spin it up. Leads to workforce limitations. You have the capabilities at a small hospital might have a very highly complex solution, and you need very specialized IT people or to train your existing ones. And of course, that takes money and time. And then operational resources, implementing any new initiative, consume charges. Those are the primary challenges we see, hear, learn about, and publish. So then the biggest aim from those challenges, or how do you work to address that market, is you do kind of the opposite. Provide access to technology. So scalable. If you want to get into that market, you create ability to size correctly, where you can start small and grow as needed. Passive RFID does a really good job of that. Geographical distance. We've created a program where we can put a person on site for probably like 1 day or 2 days to be able to actualize these passive solutions, and everything else can be online to support those people. We can talk to it remotely, we can keep it updated remotely, and so on. And what that means is you have access to technology. It doesn't have to be a person in your town. So then deal with financial constraints. So initial cost, we have as an example, we have a subscription model that has a very low startup cost, and then you tailor your subscription to have whatever's the recurring cost meet your needs and or your budget. And then value. Again, we try to package things into one solution that comes with a bunch of stuff that can optimize the value for customers in that market segment. And then you go to work on addressing workforce limitations. So generally, it's very good people at these hospitals and small rural community hospitals. But if you can make it simple to remove all this complexity, you don't need to be specialists, and you serve as the specialist, then you're doing them good service. Then operational resources, we offer it bundled to be able to park people on site for a limited period of time, get it up and running, and then support that very well. Next is examples of these solutions. So this is what a typical passive solution looks like, or can look like, or does look like in a hospital. It's not necessarily just Pycube, but anybody who wants to do this, you can put a tag on an asset, use a handheld reader to scan that into your system, then deploy that asset, go find that asset in what room is it in, do whatever preventive maintenance or servicing, and then update either physical or electronic logs. The underlying technologies would be the RFID tags, the readers, and then the cloud services that I described. And there's the yellow one here is a solution called a CMMS. It's computerized and maintenance management system or solution. And that's where records can be kept regarding all your assets. In some cases, small hospitals, rural hospitals may not have a CMMS to keep it in logs or to keep it in a spreadsheet. And our Active solution actually allows a very general CMMS to be incorporated, that they can simply use ours, or you can go to somebody else's CMMS. But then you update your log and your schedules. What's it buy you? You end up with the whole solution buys you faster equipment locating, logging and locating, and then your equipment entry, logging and maintenance is very simplified. There's also larger scale solutions you'll see. We offer them, other competitors offer them, but they're still the same kind of underlying stuff. Is you have a tag, you enter it into your system, you deploy your assets. You may have handheld readers, fixed readers, walk around park readers, whatever. You go find your assets, you maintain them, redeploy, optimize them, whatever, and basically the same underlying technologies. But you may have choke points and you may have fixed antenna readers. So now let's look at some of the features and benefits. So in passive RFID solutions, for example, our Easy series, you have zero fixed infrastructure. So you can get this up and going. No wiring, cabling, or equipment is needed. It's cloud-based intelligence. You use passive RFID, no batteries to explain, to replace, and better yet, no lost articles whenever a battery goes dead and the tag's not talking to you. It has a broad scanning mode that you can identify a whole room of assets and inventory in a couple of seconds, and then a narrow scanning mode if you have a needle in a haystack and you say, oh great, there's 120 pieces of equipment in this room. That's nice, I've moved all 120, but I really want to find just one or two. You can go to an arrow scanning mode, kind of walk around the room and find it 3 feet away from you. They have the capability of doing what we call direct detection as well as promiscuous detection. So whenever you're locating these articles, assets or inventory, you want to find just those two, it's actually still detecting everything else it finds. And so you leave the room, meanwhile, you just took inventory of everything that's in the room, presumably that's what you want there. Passive RFID is low cost. You end up with kind of solutions that will have one low price and then low recurring cost per month compared to other types of solutions. And they can be expandable, which then will more tags, more readers, more users. So this is the typical applications for small and rural hospitals. Facility inventory, supply inventory. Is a room ready? Does it have all of the supplies in it for the next patient? Loss identification, instantly identify what equipment's missing, depending on the savant and your analytics consumption. How much supplies did I complete? Laundry loss prevention. We find that customers lose a lot of telepaths that get rolled up, put in with sheets into laundry codes, and then they go through the laundry and they're destroyed. So by scanning the laundry code before it goes into the laundry process, you might find 3 telepacks that are in that bundle of solution, and or its sensors and or its cables. And then you can produce whatever operational reports and analytics and so on you want. In biomed labs, they have to quickly go and find assets that move around. You can track the movement, you can schedule and locate just those things you want to find for PM recall. So you don't have to walk around and do inventory for everything. Say, here's 8 things I need to find today. Here's where they should be. I'm going to look at them, and if they're not there, we can determine where they move and find out where they're likely going to be. Or, with fixed solutions that we offer, it's much more expensive, but you can do instantaneous to be able to say, oh, I can tell you right the second where this is. Accurately identify rental equipment, and then again, get operation reports. So that's the end of the main piece here. I'm going to talk 1 minute about bonus piece. How well does it work? Okay. So if you recall what I showed you here a moment ago, the simplified circuit. What really makes a lot of it happen is how much margin down here in the red area. How much margin is there? Did I detect that? And did I have enough headroom after I detected it that I had a good read? And you then plot that onto a theoretical curve to be able to say, oh, there's an area that's unused. So I'm sorry, 2 ways to determine success. It's binary, did I read it or not? Gradient success, how much margin is there? We're real big on this. So we do an awful lot of testing and exhaustive math. We joke between ourselves that we have these 1,000 row by 1,000 column spreadsheets that analyze every tag, and we do. That's not too much of an exaggeration. What you can tell is, hey, here's the area where it's unusable. Here's the area where it's minimal. Here's where it's okay, and here's where it's really good. So between the readers we use, tags we use, and the methodology we use, we have very high efficacy. And we've done field tests. So in one South Central Pennsylvania hospital, we were invited to come, and they had over 8,000 articles in this buildings that had been previously tagged, but their systems that they were trying once upon a time just weren't working right, had issues, and they never furthered it. But what they ended up doing was inviting us in to find that. And we found, we started, after we had coffee and discussion, we walked around, 4 guys, and we found 8,000 items, and we identified what room, what zone, and so on. So we identified the location of 8,000 articles, and we were done by lunchtime. So we started about 10 o'clock in the morning, we were done by lunch. Efficacy. There's another large New York City research hospital that we work with, and they invited us to do testing in their biomed lab, in their machine shops, if you will, where they make synthetic jaws and all kind of stuff. It's just amazing. But we went there for a few days and did different tests, different tags in different rooms with different reflectivity, different ways to detect them, and different ways to aim the readers and all that stuff. And we basically found, I never say 100%. You always say greater than 99%. 100% means that nothing will ever be off. We actually had 100% evidence. So, but we put it in our report that it was greater than 99% of efficacy, that we found every tag that we were looking for. And the margin in all those assets we tested in various passes and all of those had good margins. There were most of them in the green area. There were a few in the yellow, and out of hundreds of tests, most green. So it works really, really well. So that's the end of my outbound material. So let me open it for questions.
Thank you, Dr. Howden. It was great to see you break it down into that level of detail that you did. Some of us use RFID or RTLS in our hospitals, so it was fun to kind of see you break down that technology. Thank you. Please be sure to enter your questions in the chat. I'll go ahead and get started if you're ready, Dr. Howden. One of our attendees wrote, I heard passive will not work on metal or liquids. How do you deal with that?
That's actually incorrect category. Passive can work on metal and it can work on liquid under certain circumstances. So let me explain that first and then give the answer. So whenever I'll loosely say a regular tag is attached to a metal surface, just affixed to a metal surface, that whole thing becomes a grounding. And so you're not getting like, passing through the tag, then creating a disturbance that can be reflective. You're basically grounding out the whole tag. So a generic tag affixed purely to a metal surface, no spacing or whatever, does not work or does not work very well. So there are metal specific tags. The two things happen. They will go and put some space, almost like that adhesive foam type stuff with a particular reflective area behind it or whatever. And then you can affix that. And so then the signal passes through the tag into this foam barrier and then reflects back through the tag and does its job. So those are what we call metal capable tags. We have also found there's a few, we can furnish more information, but there's a few that we found where we put them on things that were metal and yep, they work. So regular tag does not. But metal capable works just fine and you're 20 feet out or some amount of distance and it works just fine. And then others we put on metal surface itself that were metal adherent tags to like a door, a crash bar on a doorknob or on a door exit. And oh my goodness, we couldn't get back far enough and it was still reading. So it was very highly reflective for that tag on that specific metal surface. So the answer is the common view is, oh yeah, don't work on metal. And that was the case once upon a time. It's no longer the case anymore. We have plenty of examples, and you just need to talk to people who know this information well, and you can get metal capable things. Regarding liquid, a very similar thing on liquid. So if you want a jug of liquid, again, it can be capable of being reflected. What is a problem is trying to see it through liquid. So if you have a jug of water and you place a tag just on the far side of the jug of water, that water is very absorptive for the RF energy and it's probably not going to hit the tag. So again, there's ways you can use specialized tags on the jug or the jug handle or whatever it might be. And yes, you can still get this.
Great. Thank you for explaining that. All right, please be sure to put your questions in the chat. So next question, how do you suggest we strengthen this bond between this technology and furthering it in healthcare?
That's probably like a little bit of just a simple engagement method. There are some consortiums that we belong to that like the RAIN RFID, and I apologize, I don't remember precisely what RAIN means, but they have a healthcare segment that they're pioneering more, tag manufacturer, reader manufacturers. They don't sell to them, but they interoperate with people like us who do create solutions for healthcare and do then market and then sell and provide and support those solutions. So we belong to organizations like that, a handful of them, that help advance that technology and science. We also find, not to beat our chest too much, but we also find that some of this is uncharted waters, and we don't really like not known stuff, So while I'm sure it drives some of us crazy, we have done testing that is just exhaustive to be able to make sure we understand it well. So because we've also learned, then there's plenty of really great tag manufacturers and stuff, but there's a few that have data sheets that will say like, oh, read range up to 10 meters or whatever. And you got that tag and test it, and you're like, I'm not sure what miracle needed to occur to be able to make that read 10 meters, but no, it's not going to. So we end up doing both theoretical work on the parameters of that tag, aperture sensitivity, blah, 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 with our readers, our environment, other people's readers, their anechoic chambers, and then real world stuff where we go out to a biomed lab or we go out to a hospital and then we test it in that environment. So that work or that not work, and how much margin they have. So the lap all the way back is first engagement. People are working on it, engaged with people like us to say, hey, I have a need. We don't know all the needs, to be real blunt. I mean, I think we're really nice, smart people to say, oh, we know everything. Oh, no, we don't, So there's going to be plenty of opportunities for people and medical professionals to say, what I need is, and then we talk about it. So one that we just learned in recent months with this research lab was how they have to synthesize so much stuff for like medical research, and then they have to keep it for like 10 years or something afterward. And putting your hands on that in warehouses and so on is a vast job. So they're looking at us to say, hey, go find, figure out some way to allow me to tag all of these, loosely say, synthetic jawbones and stuff like that, and then I can quickly locate or what have you. And that's just one. There's many, many examples. But we would have, just us guys talking to us guys, we would never figure that out in a million years. But the minute we sit with the biomedical engineering team at this particular research center, they said, this is where our problem is. Oh, cool. Okay. We'll get to work on it. So I think a lot of it's engagement, and then we work our consortium, and we encourage our suppliers, our suppliers are generally those people who make tags, readers, things. And then we assemble that together. We're mainly technology integrator. We're real good at cloud software, and we're real good at localized software. So we pull apart, what other people develop, pull the parts together, do the math, figure out the solution architecture, make the cloud, make the savant, make the layers, and give customers results. So we know what they want. We can go to work on that within the limits of whatever the physics or capabilities. So it's more of an engagement. Call us.
Great, thank you. All right, so we did get another question. What strategy can be used to receive up-to-date locations for devices that are stationary, such as a defib on a crash cart? When looking at RTLS, some of these devices appear to drop off since the device is not moved very often.
There's two, that has two answers to it. Okay, so one is, traditional or previous RTLS. I'm going to not call it RTLS because both passive and active can be RTLS. But based on what I said a moment ago, if you look at an active system, they would appear to drop off, not so much because the device wasn't moved very often, but mainly because maybe the battery went dead, or it's in a zone that they can't read from or something like that. So in an active system, if you hadn't petted that dog for a while and its battery went dead, you can't find those batteries. In a passive system, you kind of don't have that problem with the battery being dead. But in both solutions, if for some reason it's in a room that is never gets looked at or never whatever, you need to at least have some reader, be it passive or active, some ability to read it, frequently. So what strategy can be used? Pretty good one. We are, I don't want to say we offer yet because we're perfecting it right now, or evolving it right now. But we are putting readers and tool sets onto carts that move, like a phlebotomist cart or a food cart or whatever it might be. I'll loosely say food cart. I don't think we're really going to do a food cart, but something that goes around the hospital. Again, it's just promiscuously gathering all kind of data. This mail cart or whatever it might be. It's going around, well, it's carrying a reader and it's gathering everything 4 times a day or whatever it is of where those things are. And if you promiscuously have enough things that are looking at that, and maybe then even if you choose to have fixed readers or zone choke points, that something came through a choke point. It went on the elevator at 3:05 this afternoon. We got off the elevator at this other choke point on the 5th floor at 3:06, and then it went over in this area. You kind of can start to know, predict, analyze where it may have moved to. But again, at the opposite extreme, if it's an active tag, battery went dead, or a passive tag, when you never ever go into that room and read it, all you know is the last place you see it.
Thank you. All right, we have time for one more question before we wrap up. Is changing the battery really such a big deal? We have to touch the equipment every year or two anyway.
I'm not the person that does that, so I'm probably not really qualified to say it is or isn't. We have been to plenty of biomed labs, hospitals, and I think that posture could be fair. Hey, I got to touch it anyhow. Do I mind having the batteries? Yeah, very fair posture. But also, we've been where the people are practically swearing that I hate changing these batteries. They have racks and racks and containers, battery after battery after battery, and they have to change. Maybe changing one's not a problem, but if you have to change 8,000, might get on your nerves a little. And so this one place we were at, they really did have 8,000, and they just have a sea of batteries, and they have to cycle them every year, throw them out, or how often they choose to change it. I'm not sure if it's every year, every 6 months, but they were commenting on how often they have to change batteries, go through batteries, the expensive batteries, and so on. So is it a big deal? I don't know. I never did one for a day. Some of my colleagues have. I haven't. So I don't think it would be that big of a deal to do one. But whenever you look across the entirety of your asset base, the one hospital we did in New York City, they were at 150,000 cents or something like that. And so they did some of the math for me. I don't remember it right now, to be honest. But so it was a $10 battery or a $5 battery, or whatever, times 150,000. That's a reasonable expense and a reasonable amount of time we have to do it. So I wouldn't base the decision just off of batteries from no batteries. I would look at it in totality. What's it cost to get a solution spun up? And if it's a battery powered one, you have to have an awful lot of it, $500,000, $1 million worth of infrastructure, depending on the size of a hospital, but maybe an average hospital has $1 million worth of infrastructure, and more expensive tags. And they are along the range. Absolutely the same. That's the biggest benefit is it can go 20 meters, 30 meters. But then you have the expense of the tag and changing the battery, and you leave it up to the customer to say, okay, that's an expense I'm okay with, and here's its other pros and cons versus, well, guess what? I don't need any infrastructure. We're very low infrastructure, and the passive tags are pennies. The service from passive tags every month, cloud solutions pennies, and it's a very affordable solution. So both have their merits. Passive is kicked into overdrive and it's rocking ahead really hard. And that's where we're putting our aim. So yeah, both are good technologies, but we're betting on passive.
Great. All right. Well, thank you again, Dr. Howden, for sharing your knowledge with us. And thank you everyone else for joining us. The recording and slides will be available on the website. So please be sure to take a look at that for anything you might have missed. And also be sure to complete the survey, which will be sent out afterwards. And happy HTM week, everyone. Thank you.
Thank you, guys. Appreciate being here. So long.
Thanks.